Today I'm working on a machine to try and quickly, repetitively drill this hole into these things. I have to use these different new kind of heads on the pressure pointer head here, and so this one I made in the lathe, and it works good. And you just stick that on there, and I put some wood glue in there. And on here you can see there's some little grooves in both the linear and axial direction there, or radial direction. And so when the glue dries on there, it holds on tight, because the glue obviously doesn't hold the plastic. But that's today's challenge, is how to put a bunch of holes in these real fast, because that took a long time, or that would take a long time to drill it, and hundreds, thousands of those on the lathe. So let's see how that turns out. In Solidworks here, I have the profile of the part drawn up here and dimensioned, and about to revolve it here. Hit the revolve button. So there's revolve, and that looks good. So that looks about like the part. I guess we could add a couple little fillets and things, maybe like here or something. But let's call that good. We're going to put a 1/4 inch hole in the bottom. Not that I have an exact reason why right now, but I think in the future I'm going to need that. So we'll just put it in for now. So there's a 1/4 inch hole, a 1/2 inch deep in there, and we'll adjust that later. Let's save this and open up a new part. And the new part I want to do, we'll just make something on the front plane here, because this part is going to be a test part I want to do on the 3D printer to figure out how I'm going to make the rest of the index wheel, or whatever wheel we want to call this thing. I think I'm going to start with this about 1.5 inches long, and maybe about 3/4 wide, and we'll extrude it up about 3/4, and we'll put our finger part inside there, and see how that looks. Let's save this as a finger nest test, and then we'll do a new assembly, and we'll put our finger nest test in there, and then we'll put our finger part in there. We'll insert this part inside there, and we'll use the assembly to make features in this part. Let's start by editing this part, and the first thing I want to do on this part is I'm going to put get normal to it there. I'm going to put a center line on here, and I'm just going to draw a circle in the middle here. It doesn't matter what it is, because I just need something to get concentric there, and that'll be fine. And let's do that, and then I'm going to get concentric to that. Let's flip it around the other way. This one, let's do a distance offset on that one. I want to put that one, I don't know, let's try 0.3 for now, and let's check it out here. Yeah, so that looks okay, so it's inside there. Now we use this part here again. We'll edit this part, get normal to it. What I think I want to do is, before I do that, I want to put a plane on. Let's see where the front plane is on this thing. Yeah, it's right there. So let's insert a plane. I want to get in the middle of this. I'm going to insert a plane there. half of 370 or half of 750, which is 375. Okay, now I'm going to get normal to it. And then we'll turn this on. And then I'm going to sketch on here a line. Let's go from about, I'm going to go from a little bit outside of there. I'm going to come down to about here, and we're going to change all this as time goes on here. What I want to do is kind of make a couple of wedges on here, real sharp or sloping wedges, so that this thing gets wedged in as the drill press is pushing on it to kind of hold it. Maybe I can just do it with one wedge here. And the reason I want to do, then I got to go to the middle here. And then I'll come right through the middle and back over to here. And what you'll see here that I want to do is a revolve cut. And we're going to rotate around that thing. So there it is. Let's see if it'll show it. There it is. And it's got the wedge in there. And then I can set some dimensions and things on there. Let's go ahead and do that while I'm here. We'll set that 0.15, I guess. This dimension here just going to be just big enough that that goes through. So what's that going to be? 31, I guess. I don't know. Let's make it 320 or so. And again, this is just going to be a test fixture for the 3D printer, and we'll modify all this. Let's see. Do we want to set the depth of an angle? I say we set an angle. Let's see. Let's set it this way right here, and let's set it. Let's set it at 6.8 degrees. I don't see any reason why we don't want to do that. And this here, let's set this depth. I'm going to set the depth off of this part here, so when we set the depth of the part, it will move there. And let's do that. Oh, it don't like that. What doesn't he like there? Oh, because it can't find that hole. All right. Well, I don't think we need that dimension, that mate anymore anyway. So that looks pretty good there. And so now what I can do is make this one concentric with the one that we just made, and then that'll hold that concentric mate in there. So that all looks like it's stuck down in there. And so let's open this part. Yeah, so that looks good. Not sure. I might want to change the depth on this slope here and the total depth and things. One other thing I want to do is add a thing in the top here that I want to push a flexible tube around a corner and push the thing out. So let's try and do that. I think I'm going to do that. Get normal to this plane here. Draw a thing on here. I think I'm going to do that with a line here. Maybe we'll go straight just for a little bit. And I think we might make this a little longer because that's a little bit tight of a bend. I think I want to put like a 1/2 inch radius on it, somewhere in there. And then I want that to be tangent. And we're going to come out straight like that. So let's make this tangent here. Oh, he don't like that tangent. Why doesn't he like that? Somebody's fixed. There we go. All right, so now we can do the tangent. Let's do this radius. It's close to 0.5. We'll make it exactly 0.5. Now the lines are black, so they're defined. That looks good. I think what that means is that I want to make this whole part a little bit longer. Let's go ahead and do that. Let's make it 1.75. Let's see how that looks. I could have hit update in there, but I didn't. Oh, I think, did that work? Maybe I didn't want to do that. Let's back. No, see, it made the top and the bottom both added length to it. Let's just add some to the top here. I'll convert those entities on there, and let's just add some to the top. We'll add a 1/4 inch to the top there. Okay, so that's a better way to do it, I think. Let's see. Okay, now I'm going to get inside here. I'm going to draw on that plane a circle. Make this 5/32 because that's the size piece of tubing I'm going to try and use as a pusher to push out of there. But I want to add some clearance to that. Maybe let's try 25 thousandths just for our test here. So we've got 2 sketches there. I've got one on that plane, that circle, and then one on this plane here. So I'm going to pick that sketch, and let's do a sweep cut here. And looks like my profile looks okay. And there it is. It swept that cut. So what's going to happen here is, let's get normal to this plane here. The part will start upside down like this, and then hopefully the part will fall in like that, and then the part will rotate. The whole thing will rotate this way, and the drill will come from this side, and hopefully push that thing into the wedge, and that'll hold it from spinning and drill its hole. And then this will spin a little bit further down, rotate. It's actually going to rotate, and then the flexible tube will come in and hopefully push that part out. And let's see if we can make that work. I think we're ready to test print this part.
All right, well, that didn't go so well. I don't know if you can see, it didn't stick to the bed very well there, and on this back corner, I think that made it kind of make some warped holes and some things there. So that's not very good as far as being round and things. We're gonna have to think about that for a minute and come back and revisit that. Out here in the shop now, and this is the part that we just made on the 3D printer a little while ago, and it didn't come out as bad as I thought. I used this. This is a 5/8 inch piece of steel here, and I just heated it up with my blowtorch here, and rounded that out to the 5/8 diameter of this. I tried to use a drill, but the drill didn't do anything. So the warm tube just kind of pushed it out to the right dimension. So now my part fits in there nice, and when I turn on the drill press here, it does exactly what I wanted. It goes down in, wedges itself in there, and holds it in there, and I can push pretty hard on there, and the part doesn't spin in there, so that's great. Now I got a little bit of a problem because I can't get the part out. The 5/32 tube, remember, was supposed to be in there, and I was going to push on it mechanically and push that out of there. But instead, I hooked the 5/32 tube up to my foot pedal and my pneumatic air. And now to get the part out, you just push on the foot pedal. But the part now gets blown off onto the drill bit, which is kind of cute, but whoop, there, fell on the floor. But that's not great. So I'm going to make a little thing here and hopefully deflect the part away, and hopefully I'll catch the part in my hand when I push on the drill bit, or push on the foot pedal next time. We'll see how that works. All right, so I got a piece of wood here, cut it to the right height. It's got a slope on it, and I'm just going to glue this piece of little steel here on it just for a quick test here and just see if it works. I'm going to preheat my plate here. I have a hot glue gun, but if you stick hot glue to cold steel, it doesn't stick very well. So I'm just going to preheat this a little bit, and since my glue gun's not heated up, I'm going to do another thing here. I'm just going to use the torch to heat the glue. And I can see that this isn't very hot yet. So we'll just heat this up a little bit. And having the part shoot up and shoot onto the drill bit, it's cute. But it's been annoying. It's starting to warm up now. All right. Quick test. One on the glue here. We'll just stick that in there. And then this here. Yeah, this is going to be just fine. That's going to go about right there. And that worked so well on there. I'm going to do it on here. You don't have to preheat the wood, obviously. But this steel's not very thick here, so I don't have to do a whole lot of preheating. But if your glue gun's not hot, that's a quick way to do that. So I'll use this as a guide here. And that all looks good. This all looks good. I like all that. Turn the torch off. We'll let that cool for just a minute and be back and see how that works. I got my part here, and load the part into our fixture. Turn on the drill press. Drill wedges in there nice. Everything goes good. Push on the foot pedal. I'm gonna have to get good at catching it but it blows it right out. Blows it into my hand in there, and I'll just have to get good at catching it. But, oh, I caught it. So it works great. I like it.
And then, just to test the 240 frame per second recording rate of my camera, this happened.
So that high-speed video was kind of fun, showing the deflector getting blown off. But so I'm trying this viscoelastic tape. This is this 3M very high bond VHB, they call it, very high bond two-way tape, and doesn't really dry apparently, and so it stays liquid and oozes into the cracks and crevices, and that's how it sticks. So it should be very resistant to shock, like having a little piece of wood shot at you like a cannon. And one of the things I like about it is that it is kind of like super glue or wood glue, or super glue or hot glue, in the sense that it's pretty much instant. So let's try it. This is not at high speed, or high speed video, but this is just a test here. All right, so that didn't work. I think that tape's going to work. We just need to let it sit on there a while and let it soak in. So my viscoelastic tape didn't work so great either. We'll just do this the brute force way. Just drill a hole in there, put a screw in there. I'm disappointed that I couldn't use glue or two-way tape, because that would make it more fun, but just put a screw in there and put this thing back over here, and line everything up again. And now we're back in business. Let's try it again. With the screw in. Air pressure. And the cannon works. I'm gonna have to get good at catching that. That was a little off. Well, I'll practice that.